Hello, everyone. Welcome to this panel session. I'm very excited to be here with this exciting panel on this very important topic. We hear more and more about larger wildfires from California to the Amazon rainforest to the Arctic Circle to Australia. And every year, wildfires consume millions of acres of land around the globe. And in this panel, we will discuss how technology and advancements in AI and machine learning can help to mitigate wildfires and reduce the risk of wildfires. But surely technology alone cannot solve the problem, and collaboration is key. So I'm very excited here today to be on this panel together with Allison Wolff from Vibrant Planet, Kian Mirshahi from Mayday.ai, Dr. David Marvin from Salo Sciences, and Dr. Natasha Stavros from University of Colorado Boulder. Myself, I'm Indra Bakker, CEO and co-founder of Overstory. Our mission is to help solve our climate crisis by providing real-time intelligence about the planet's vegetation. By applying machine learning to satellite and climate data, we provide actionable intelligence about vegetation at scale. And the first market we address with our vegetation platform are utilities. One of the key reasons for wildfires are trees interacting with power lines, and this problem is getting worse with our changing climate. So we help utilities to get an up-to-date view of vegetation. We help them to plan ahead based on risk and verify pruning work by third-party contractors. Some of the underlying data features are tree species, tree health, and changes over time, surely topics we will hear more about in this session as well. And I would love you, Allison, to introduce yourself as well.
Sure. So I come from Silicon Valley, and I run a company called Vibrant Planet. My career in Silicon Valley started really at Netflix, where I was head of marketing and brand in the very first few years, and did a lot of the user experience design for the product. And from there, I went into the consulting world and was sort of an embedded consultant for many years at a time with eBay, Google, and Facebook, and worked with those companies on a lot of their sustainability strategies and implementation. Did a lot of their data for good programs as well. And I got into this space through some strategy work for founder families, and started to understand how catastrophic the forest health situation is, where climate change is intersecting with land management practices on both forests and ag lands, and just got really passionate about the role natural climate solutions are going to play in drawing carbon down. Having worked on a lot of campaigns and efforts to move to renewable energy and stop fossil fuels, I feel like there hasn't been enough focus on natural climate solutions when I think they are maybe one of our biggest solutions. So a lot of the impetus for me getting into the field that I'm in is that, but understanding how wildfire is flipping forests to being net carbon emitters, wanted to focus in on some of the technology gaps that I saw in the space to actually help with much more effective land planning, and doing that in a very adaptive way so that we can learn what's working and what's not working over time. So that's what my team and I are building.
Very cool. Thank you so much for the introduction. Very interesting journey so far. Curious to learn more a bit later. Kian, can you also introduce yourself?
First, thanks for having me. Kian Mirshahi, founder and CEO of Mayday.ai. I come from a career that's been really focused on innovation and transformation for the past almost 2 decades in different industries. That's just been my area of interest, where I want to go to areas where there's a lot of room for improvement, and has been very disruptive in the sense that new ideas, new strategies to create efficiencies, and really approach the problems that we've had in many industries differently. About a few years ago, I was actually in the middle of a wildfire, being a California native, and it was almost 20 minutes later before I got the first notification about the fire. And I just got to learn so much about this industry, just out of interest, to see how fragmented it was, mainly because of policies around jurisdiction management, disparate systems, cultures that are mostly reactionary, and the consequence of it, which is permanent damage to our beautiful heritage. A lot of these wildfires are causing permanent damage. So I enjoy being outdoors, and I enjoy doing a lot of, especially with California's nature. I'm seeing it firsthand where a lot of these habitats are being destroyed. As you know, it doesn't stop with wildfires. It ends up being mudslides because of the soil integrity being destroyed, or volcanic activity that leads to earthquakes. And as you know, what happens in California doesn't stay in California. The pollution travels across the globe, where you have all these new particles that have no business being airborne in the first place, traveling across the globe. So it is truly a global problem. And quite frankly, it's not a capability issue, but it's a cultural issue. It's a policy issue. So I got into this business by essentially a cold call to NOAA saying, hey, I really like these sensors that you have from 22,000 miles above sea level. Can I try them? I have this idea about real-time detection. So I think first they thought it was a prank call, but they entertained me, and they said, you know what, sure, there's a big data program that you could try. And sure enough, a few years later, we've been successful in seeing essentially all wildfires within their first 15 minutes of inception, from 22,000 miles above sea level, through daily machine learning, where we can see through clouds, and have added essentially other layers of sensors with polar orbiting satellites, some 200 sensors, some 32,000 traffic cameras, as well as social media sentiment analysis, to truly provide a platform that gives you sensors, as many sensors as possible, to help with a culture that focuses on resiliency and prevention. So I truly believe this, especially with wildfires, if we think about this in a different way, they're preventable. Quite frankly, out of all our problems, wildfire is one of the easiest ones to solve if we think about this problem differently. So I'd be happy to talk about this a bit more as the conversation expands, but it's a pleasure to be here among such an esteemed group of accomplished colleagues. Thanks for having me.
Thank you so much. Great to have you as well. David, can you explain a bit more about your background?
Sure. Hi, everyone. I'm David Marvin, co-founder and CEO of Salo Sciences. We are a relatively new company that's focusing on building technology that can drive the implementation and scaling of nature-based solutions to climate change. And unlike a lot of other organizations out there, we're led entirely by forest ecologists. We think that's really important because we're focusing on mapping a lot of the fundamental ecological variables that underpin a lot of the problems that we're seeing right now, including wildfire. As everyone's aware, wildfire needs fuels, vegetation fuels, in order to occur. And we're really focusing our efforts on mapping really timely, highly accurate vegetation fuels across very large scales. And briefly, I'll just show what that looks like and some of the use cases. And this, the first system we built is called the California Forest Observatory. This was built in partnership with Allison, Wolff at Vibrant Planet, and Planet Labs, the satellite company based here in San Francisco, with funding from the Gordon and Betty Moore Foundation. It was launched just about 6 months ago, and it's just right now currently in California. But the idea behind it is to use satellite, small satellites, government-run satellites like Sentinel and Landsat, to be able to map high-resolution annual vegetation data. This includes both fuels and forest structure across all of California. What you're seeing here is canopy height across a oak woodland in California, darker green being taller trees. You can see we're getting really detailed patterns of height across the landscape. And this can be used to drive wildfire models, but can also be used in a lot of other really interesting use cases. For example, mapping potential strike trees across the entirety of California's utility grid. Because we can map not only location, but also the height of each tree, we can detect their potential fall-in risk, which could lead to ignition on the electricity grid. Once you have a fire that does occur, we can also rapidly map the post-fire burn severity across the landscape. This is the North Complex from last year, which ran about 24 miles in about a single day, burning at very high severity across the landscape. And then finally, as I mentioned, being able to do these wildfire hazard assessments using much higher resolution, more accurate fuels, we can get down to nearly the parcel level and look at wildfire hazard across the entire state. This provides much better information on where we need to prioritize defensible space, fuels treatments near communities, and overall forest restoration to reduce high severity wildfire, not necessarily reducing wildfire overall, because in a lot of cases, as we'll talk about today, wildfire can be a really good thing to have on our landscapes.
Very cool. Thank you for sharing. Natasha, do you want to give a short introduction as well?
Sure. Hi, I'm Dr. Natasha Stavros. I'm the director of the University of Colorado Boulder Earth Lab Analytics Hub. We do novel data integrations, everything from social media up through drones, remote sensing, to tackle problems. But a little bit about me, I'm a Megafire expert. I was kind of one of the first scientists in the field to try and quantify likelihoods of extreme fire events happening. Started doing that over 10 years ago. And since then, I've been I worked as a system engineer with NASA. So kind of trying to really think holistically about problems, thinking about them more from not just from the lens of, okay, there's a fire, what are we going to do about it? But, you know, why do we have a fire in the first place? And what is it that makes a fire a problem? And I think this is really important when we're thinking about it, because we really don't want to be thinking about, oh, all fire is bad and suppression is the way to go. In fact, for millennia, humans have been living with fire, using fire as a tool. And it's really important that we continue to have fire on the landscape. The thing that we need to think about in the broader context is, how can we live with fire in a way that doesn't impact us by losing lives, damage to infrastructure, and toxic smoke? And so you really have to think more holistically. And so that's a lot of the work that I've been doing. I will share something that has been coming out. So about a month and a half ago, some leading change agents got together and we really started to talk about, what does a solution space look like in this arena? And I just want to sort of emphasize that there's all these different areas that we need to think about, from the policies that are at play to the economics and the financing and the business models. That's something that we should talk about. It's very hard. As mentioned, it's a very fragmented landscape. So what does that look like in a sustainable business around the technologies and the things that we are creating? There's sociocultural components to this. So human behavior and AI really is going to play a big role. And so that's something we can talk about. And then, of course, there's the technology, which is just what data is available, how do we use it, how do we make it openly accessible for people. So I won't belabor this too much, but just to say that I'm really coming at this from a fire expert and system thinking perspective. And I see machine learning and AI very much as a tool in that much larger context.
That's a great last sentence. Fully agree with that as well. I think that's an important thing to keep in mind. I think we have a very technical audience, very interested in advancements in AI machine learning, but I think it's very clear that it's part of the solution. I was interested, I heard your introductions, both Allison, Kian, you elaborated why you decided to move in this field. Allison, you had an impressive career in tech. And I think it's very inspiring to hear your personal journeys. And we see a lot of talented and experienced data scientists, entrepreneurs, engineers, individuals, business people also leaving their careers to work on solving our climate crisis. Do you have any advice for the people that want to make this jump?
Jump. That's what I would say.
Jump and know that it's a marathon, because it is a cultural change. You're changing habits and minds, hearts and minds. And as creatures of habits, it's very hard to change a lot of those. So be very patient. And jump, definitely jump.
We need you all. Coming from the academic sector and moving into this, it was a much more natural transition for me. But honestly, we need all types of talents, all people from different backgrounds, from all over the world. This should be all hands on deck moment. This decade is critical to getting things moving on climate change.
Yeah, and particularly in the tech space, one of the things we've been able to do is combine talent from Silicon Valley. So we've got the head of product and engineering from Netflix, Neil Hunt, who was there for 18 years, literally built Netflix. as our head of product, we have our CTO built Lyft. He was most recently working on the self-driving car initiative, which is a very similar data problem. So having his brain in this space with our forester, who's working on the ground to hack through these really difficult forest planning processes that can take 2, 5, 10 years, getting their brains together to create new ways of doing forest plans has been an unbelievable step change. So that we need the technical talent, we need, just on the AI and ML side, getting more data scientists, more people that are really adept at machine learning is a huge need. So I encourage all to jump. Communications as well.
Couldn't agree more. Yeah, no, thank you for those great suggestions. I think we need all hands on deck, what you said, David. We're already past that moment that we need all help we need. Maybe to take a step back, Natasha, you showed one slide, I think, from the talk about the wicked wildfire problem. I think take one step back. Can you briefly explain the difference between a wildfire and a megafire?
Yeah, sure. Wildfires in general, this is kind of like the term used to describe fires that happen in wildlands. And natural fire is used to describe fires started by lightning. And megafire is this socio-political term, completely not quantifiable. It has to do with the impact of the fire. So this is really kind of asking us to step away from the current lens that many people think about it as acres burned or really acres burned is the number one thing. But there's, a megafire can have impacts on, it's really the fires that matter. And so, big fires matter for smoke. So which are the fires that are going to turn really, really big? Those are the ones we want to focus on, not all the small fires. Fast fires matter for lives. So how fast, if you do have a fire, how fast is it likely to travel? And where are your access and evacuation routes? And what are the optimal ways of getting people out? And how do we communicate that? Knowing that we're in a potentially low bandwidth, low access area to tech. Lastly, proximity matters for infrastructure, right? So it's not all fires, but which fires are within this buffer of where we have valuable assets, whether it's homes, power plants, water distribution centers. And so we need to start thinking about fire, not just like all wildfire, but really the mega fires or the fires that matter in the context of this. And so when we're thinking about machine learning and AI, how can we integrate these other factors in to not just say, oh, well, I've detected fire, but I've detected a fire that could matter.
Yeah, I think that's exactly why we need that collaboration that you also highlight, I think, in your talk. Like, how can we stick all these pieces together and have a real solution that have a real impact on what matters the most? I think, Allison, you can probably give a bit more context around the perfect storm that can lead to a mega fire or even a gigafire.
Yeah, I'm happy to. And if it's okay, I will just use some visuals for this because I think it will help with the get. So really quick context. So 2020 was not an anomaly. This is, as Daniel Swain, the climate scientist, said, this is not a new abnormal. It's going to get a lot worse. So it's sort of a good baseline to think about what we're in for here. So one of the things we're focused on is really dimensionalizing. There's a lot of money and focus on fire suppression. So how do we get better early fire detection systems, bigger, better planes? I totally agree with Megafire. Unfortunately, what Natasha was getting at is, once megafires start out in the wildlands, we've got all those that perfect storm. I'll get into what that is with fuels and climate change winds and all of that. They're moving at these impressive speeds, and they can become unstoppable. And so we keep throwing a lot of money at fire suppression, which is causing more fuels. It's sort of this feedback loop that's not so great, where we suppress fire and then we have more fuels. And so what we're trying to figure out is, how do we help people see the full picture of damage, not just in terms of what we're paying for fire suppression, but also some of the impacts, beyond property damage, which is huge. I mean, the insurance industry lost 20 years of profits just in the 2020 California fires. But also starting to look at things like public health, that downwind smoke impact that Natasha talked about. And then we're really focused on the ecosystem services loss. So just in 2020 fires, we lost $4 to $5 trillion worth of water reliability, long-time carbon storage in the trees, biodiversity, if we can put a value on those things. So it's a really big deal. And that doesn't include $4 trillion in wood products that is really valuable. And then of course, we've got these huge impacts. We've got this new feedback loop in climate change, positive feedback loop to the climate. A lot of people don't know that forests in the West store more carbon than tropical rainforests. And so we're losing this massive amount of carbon in these megafires when they go up to the canopy. And then in a lot of places, we're seeing forests convert to grasslands and shrublands that don't store as much carbon. Health impacts are huge. The water impacts are massive, with 75% of water in the West originating in forests. And then of course, we're watching insurance companies pull out. There's all kinds of economic vulnerability with that. And so how we got here, this megafire problem, and Natasha can pipe in and correct me, or Dave, but we basically, the story is we clear cut in the entire of North America, right? We're very focused on deforestation in tropical areas, and we have to stay focused on that. But we forget that we did it here first. So there's really only about 3-4% old growth left in the Western US. And what grew back were these very homogeneous forests. So kind of similar species, all the same age, growing too thickly together. And then we've had this 100% fire suppression policy where, for 130 years, we've put every fire out. We're very, very good at it already. And so now you've got a bunch of ladder fuels that have grown that would have been cleaned out by some of the cultural fire Natasha talked about, and lightning fires that would burn low to the ground and sort of cleanse the forest, move carbon, move nutrients. It was a very positive kind of fire. And then we have more and more people moving into the wildland interface, and we get better and better at fire suppression. We also have bigger fires starting with transmission lines. And then you add climate change to that, and you've got aridification where the atmosphere is sucking moisture out of the vegetation to feed itself. And then you get these really dramatic pressure gradients off the deserts. And then these what would normally be regenerative fire along the ground gets laddered up with ladder fuels to the canopy and then carried at these speeds we've never seen with climate fueled winds. And so that's where we're getting this catastrophic loss of human life, human infrastructure. And then also what we're concerned about is these really important ecosystem services out in the forest. And so the good thing, so I've worked on climate change for many, many years, including at some of the tech companies I was in. We know what to do. So we can actually sort of mimic the role fire played, that healthy fire in these ecosystems, what it played over these years by mechanically thinning out what would have been burned out by kind of low intensity fire, that healthy fire. So we can kind of restructure forests to be resilient into the future. And then over time, manage with fire again, as the Native Americans did for 20,000 years. And the problem we're focused on, I'll just lay this out really quickly, is that planning a restoration project in the forest can take that 2 to 10 year timeframe. So the problem, in California, we could lose most of our forests in the next few decades. So we can't take 10 years to plan a project. And then we don't have enough workforce. So we've got to train up and deploy a workforce really efficiently. And then we don't really have a system for prioritizing resources. Where do we spend money? Where do we want to unlock biodiversity? Where do we need to safeguard the carbon stores we have? Where do we have watersheds that are at high risk? We don't know where to go right now. And so we need better mapping tools. That's where AI and ML is going to come in. And then we need to know over time, are we making the right moves? So once we actually do the work on the ground, are we winning? Like, are we actually mitigating the risks to people, but also these ecosystem services? So that's what we're focused on, is creating this sort of adaptive system to help us get smarter and smarter over time on what's actually working and what's not working, and getting more work done on the ground faster.
That was,
and I think, sorry, yeah, please go.
I was just gonna say that was beautifully said, Allison. It's like very, very nice and clean.
That means a lot coming from you, Natasha.
The only thing I would add to that is just, when we're thinking about that prioritization, is just to like remember to that there's like a wealth of perspectives and places where we can get that information. So it's not that like, oh, in colonized United States, we have to figure this out from scratch. I want to sort of reiterate that, for millennia, Native tribes around the world have been using fire very effectively and building resilient communities, and they've prioritized areas. And so there's a lot of locked knowledge in those cultural histories. And so when we're thinking about it from that perspective, I just want to kind of remind us that we're not starting from scratch.
That's right. And what's interesting too, just for the audience, is Nature Conservancy, where Dave used to be, has a partnership with some of the tribes called Treks, where the tribes are actually training burn bosses. So it's a really cool kind of turn of events in my mind. One other thing to mention, when in the forest planning process, often we default to sort of what we call the easy acres, where it's sort of obvious to do fuel breaks around towns. And then the Forest Service, which is 60% of land in California and most of the West, has timber targets still, where they have to take big trees for board feet. It's from like the 1800s economy where we built railroads and mines. And so a lot of the forest plans default to those two parameters. And so what's happened is we've had more and more fuel buildup because we haven't focused further into the wild urban interface or further out into the wildlands where fires are starting. So Paradise is a little bit of an example of that, where they did a really big fuel break around the town. They did tons of defensible space, but further into the forest, that fire started from a transmission line. And if they had cleared some of that, it might not have burned into the town, but it would have at least given them more time to get out. And so that's what we're trying to do, is put the other pieces on the table with economic value behind, like how much is that carbon storage worth? How much is biodiversity worth? So that we can sort of reframe the problem and get further into the areas where the megafires are starting before we lose a lot of these landscapes and have more disasters like that.
Thank you for sharing. Very interesting. I think very interesting to also see how it evolved over time and where we are now and where we can add value and where we need to take the learnings from all these thousands of years from indigenous people and other people, and we shouldn't be ignorant about that. So fully agree with that. And Kian, I think you focus on a very specific part of the whole chain. Why did you decide to focus on that specific part?
So effectively what Mayday is evolving to become is looking at the different cycles of an event. So before, during, and after. As an immediate need, we focused on detection because my hope is to help with early containment as much as possible. So there's a lot of work that needs to be done for the longer term planning that was beautifully mentioned and elaborated with my colleagues on the call. But there's an urgent need. So how do we focus on early detection and early containment so it can be, we can deal with these small events? And then in the longer term, the focus of Mayday is to become a platform that's really helping with prevention. That's giving those alarms early enough in a very surgical fashion to know where to look at. A lot of the risk maps that we currently look at are very broad strokes. So by default, it discourages a lot of policymakers who are, quite frankly, are not sophisticated enough in this space, just because it's new. You're dealing with folks who have AI competency and are sophisticated enough to look at 9-course meals in Michelin restaurants versus folks who are so hungry and just learning about this. So there's this gap in acumen and education that needs to be overcome by our policymakers who can then shift a lot of these just recently, a couple of days ago, Governor Newsom announced $500 million for fire resiliency. And as Allison pointed out, a lot of that is around fuel breaks and other components that are very ephemeral in nature. It is not going to solve this problem permanently. So my hope is to use platforms like Mayday, and it's not just for wildfires. We're covering 18 disaster types. We're focusing on wildfires, floods, and storms and earthquakes as the initial push, because these are the most destructive globally, and everything else fits in between by Q1 of next year through our partnership with Esri. So just to add to this, if you know where the risk areas are, and think about irrigation. We do this very successfully in our football fields, in our lawns every day. You have a sprinkler that goes up and everything is green. If you can have these evergreen environments, and we've done this successfully in Irvine or Newport Beach, for example, in some areas of California, where there's no fuel to be burnt. So the wild and urban spaces can be focused, our initial focus where a lot of these problems are happening. And truly, this is an 80-20 problem. 80% of our major fires are happening in 20% of California's land. And so first, let's make sure the policy, our national policy and our state policy are the same. It is a national security issue. This is not a disaster issue. Quite frankly, no adversary has burned 4 million acres of land than our own forests. No adversary has done enough damage to our homes than our own lakes and oceans. But we frame this problem very differently. So first, that policy needs to be aligned. And secondly is how do we clear this fuel that's gotten this far? Let's clear that fuel out first. Let's reset by irrigation, smart irrigation, through recycling our urban water. We go through millions of gallons of water every year that we waste. If we can recycle a fraction of that, and we're doing this successfully in California, we can learn from these best practices throughout the state, and we can clear some of these fuel that gives us some breathing room for us to focus on the longer reset, on the longer planning, that platforms like Mayday that are essentially always reminding you to get to this, earlier alarms reminding you to get to this problem before it's too late, can help us as a tool to be successful in addressing this problem.
Yeah, that makes a lot of sense. And I think what we also heard a lot is that wildfires, of course, the process is a bit unpredictable, the behavior, of course, and we see new technologies on the mitigation side, on the adaptation side that you mentioned, early detection, very important. Because I think audience is very interested also in the technology. So what are recent advancements in technology that had a real positive impact on this, sensors, tools, or whatever? And where do you think we need more innovation or funding to improve further? David, do you want to take this one?
Sure. Do you mean around detection specifically, or just in any different aspect?
I think it's interesting to learn more about, indeed, in the advancements in tech specifically that helped in this area of mitigation adaptation.
Sure. So I think there's three really key technology pieces that have kind of come together in the last decade or so to really push the field forward around understanding or leveraging technology to identify and understand the impacts of wildfire. One is a explosion in the number of Earth observatory satellites. And so you have this led, generally by Planet Labs. They're the first kind of small sat constellation to put up a couple hundred satellites to image the entire Earth surface once a day, every single day. So a really big advancement that now has been replicated by a number of other companies. And I think in the next 5 years, we'll see even more similar constellations of new types of sensors, especially SAR. This is becoming a really, really amazing technology to map the entire Earth's surface, even through clouds. So you can begin getting more information about structure of fuels, information about soil moisture. It's a really incredible technology. So number one, lots of more satellites looking back at Earth rather than looking away into the stars. Number two is cloud computing. Just having really cheap, hugely scalable systems to process that vast amount of data coming down from space. Really, really important. And then number three, why we're kind of all here, artificial intelligence, machine learning. And I think it's less so as much a advancement in the types of architectures and software. And it's more the access. And so the number of different software platforms that are open source and available to anyone to start working with. You'd have to be, 5-6 years ago in academia to really understand and use this technology. Today, you can go and download it and get machine learning models running on your laptop in about 15 minutes. It's really incredible. So I really think these three different pieces coming together all at kind of the same time has just opened the door to answering whole new questions and doing it much faster and at way bigger scales than can ever be done before. So I really think, and this honestly applies to almost any type of problem out there, but in wildfire in particular, being able to think at the scale of the Western United States, to be able to map out the fuel loads, to be able to run simulation models to understand wildfire hazard, beyond just your local community, but being able to do this at high resolution for huge areas I think is really, really important for both the scientists who are studying the problem and the policymakers who are trying to tackle the problem.
I could add one thing on to Dave's point on the cloud. One of the things we've found is, you know, a lot of the data for this space resides on university hard drives, and they're getting shipped around. This space has been very slow to move to the cloud. So like Dave said, the cloud has become really important. And it's also enabling companies like ours to run really complex models. So the Forest Service has, and other entities, all kinds of academia, Nature Conservancy and others have amazing models, but they haven't been able to run in the cloud yet. And so being able to run models, like we have an agreement with the Forest Service to use FORSIS, which is a nationally mandated optimization engine for forest treatments. And so we're basically bringing a scientist's model into a system that can scale it globally. And so he's really excited about that. And it just wasn't possible within the Forest Service to do that. So there's hundreds of things like that, you know, companies like all of ours and scientists like Natasha can leverage now. And then the tooling around AI and ML is becoming increasingly powerful. So between that and more data coming into the cloud, the ML AI sphere is going to grow exponentially, because, you know, as we get smarter and smarter with many points of data and then pattern recognition across those data sources, I think we're just at the beginning of this kind of rocket ship in terms of how much better the AI and ML space is going to get.
And it's interesting, all these advancements. I think you both mentioned most things that advanced a lot in the recent years, but we still probably see a gap in the adoption of these technologies. Why do you think that is?
So, sorry, I'll jump in and kind of answer that question and the other. So there's a couple of different reasons why we're not adopting technologies, but also just to say that, yeah, we have a lot of data and there's a legacy of experience in building models that integrates in our information and our knowledge. The problem is that a lot of the data sets that exist are very fragmented. They're all in customized formats and they're very hard. So data wrangling is a huge effort. That's like hands down one of the biggest problems, is that like no one really is interested in doing the data wrangling. They all want to do the shiny fun part at the end. That's like,
yeah. So, well, Natasha, so that 2 to 10 year planning time frame, half of that is data wrangling.
Yeah. Data wrangling is a huge, huge problem. So that's one of the big things, is that, you know, we see a lot of people come out with a shiny tool, but at the end of the day, it's not operational because the data management is just so cumbersome and so costly. So, you know, there's efforts through the government to kind of come up with some data standards, and we're starting to have those conversations. How do we do that? Some other sort of barriers to adoption are that we're not actually placing the machine learning and the AI in the context of the decisions that need to be made. And so what ends up happening with like many of my colleagues is like, we're on the phone every single week with a new startup who's like, we're going to solve all your problems with our shiny tool, but they haven't actually stopped to say, well, what is it that you're trying to decide to do and why is it not working? You know, and so they're not really placing the tool in the context of the decisions that need to be made. And so consequently, the tool may be very nice, but it's not actually helpful in the context of my day-to-day decisions that need to happen. So I think that's another sort of major barrier to entry. And then the last is, you know, sort of accessibility. And training, accessibility, making sure that the tools that you are developing, you know, a lot of what we do in forests is in remote locations. We don't have a lot of bandwidth. So, you know, how can you do it with as low bandwidth as possible, where it shows up as a text message on someone's phone, or, you know, so you have to think about the access. So what's the decision? Where's that decision being made? And how are they going to access that information in a timely manner to inform how they're making their decisions? So I think those are like a number of the different tools or barriers to adoption that we do see.
Yeah, and then I also want to opine on this, and just adding to your previous question. So it's not just the proliferation of satellites, but other sensors. So the Internet of Things, where you have visibility from 22,000 miles above sea level all the way to the ground level. all these sensors working together, and this is what we've tried to do with Mayday to create an agnostic engine that can take sensors at different levels and make decisions, is the evolution of AI, being agnostic to many sensors and being able to create value add services. So the space industry is going through this .com era. Being able to launch satellites means everybody from hobbyists to scientists, everybody else are going to create this massive network of sensors. The question is, what is that incremental value? What is that value added difference that can help me when I need it most? So it's not that we don't have these capabilities. NASA and NOAA have been doing this for years, but it's just sitting in some scientist's laptop. It's not democratized the way we want it to. And quite frankly, for that to happen, it needs policy that makes this accessible, but it's just the adoption curve. So AI is, if I can do this comparison, it's taking us from horse and carriage to spaceships. There's no time to go to cars. It's literally, you're going from a license to know how to handle a horse to becoming an astronaut. So you have the early adopters and scientists that can be, quite adapted and jump, but everybody else kind of goes through that adoption curve. So ease of access is great, as you're seeing with many startups like Mayday and others, but being able to use it for value add services and broad adoption is something that can be pushed towards policy, that can be pushed towards changing people's habits. So you've got those early adopters, and then you've got laggards all the way to the end, where they just don't believe in technology. So that's one component. I think the other component is, as you use these tools more and more, then AI is just going to be a part of our life. So we use computers. Computers have intelligence built in them. They've been around since the 70s. It will become a part of our decision making. So as we become more and more sophisticated, then these services can really evolve to do a lot more than what they currently can do. So echoing Allison's point earlier, we're just at the beginning of this journey. This will evolve into something that's a part of our lives, very much a part of our lives that we wouldn't even pay attention to, but truly it will change how we protect our areas because we have visibility. And one last point, we're paying a lot of attention to our climate, but what AI is going to allow with these sensors is our space weather. We're just learning about the sun and solar activity. A lot of these persistent drought conditions are caused by solar cycles. Quite frankly, a lot of people blame pollution and industrialization on what's happening. Well, 100 years ago, 200 years ago, we didn't have the same level of industrializations, but you had persistent droughts. So the more we learn about the sun and its cycles, the more we can plan ahead for these drought conditions. So it's like going from the winter to summer. We use our heaters and ACs, we adapt, we have internal kind of climate adaptation. When we know drought conditions are coming in, what can we do ahead of time to make sure these forests are green? What can we do ahead of time to prevent this from happening? This is what AI will do for us. It expands our perspective to so much more than just our planet. It's our solar system and beyond, to learn about these disruptions like magnetic fields, to learn about solar activity, plus what we're doing as humans to affect this and amplify this further.
Thank you for so much. I have many more questions, but I just got the sign that we're running out of time. I think there's many interesting follow-up questions to ask, but unfortunately we don't have the time. I would like to thank you all for being here, and thank you for your time and sharing your insights. It's been very insightful, so thank you so much.
Thank you.
Thank you all.
Great.